Hi guys, thank you for watching my previous video. Today we are looking at a new chapter called Further Application of Differentiation. So without further ado, let's take a look at the first slide. Over here we are asked to determine whether this function y is an increasing or decreasing function for x is always bigger than 1. So now we have to understand what an increasing or a decreasing function means, or how do we determine whether y is an increasing or decreasing function. So today we will take a good look at some of the ways to determine an increasing or decreasing function. So in order to do so, we need to see if dy dx is smaller than 0, or whether dy dx is bigger than 0, or even you will get dy dx is equal to 0. So let's further analyze what dy dx is smaller than 0 means. This basically means your slope is a downward slope, and because of this downward slope, your dy dx is smaller than 0. So you have a negative gradient for dy dx is smaller than 0. And therefore this shows a decreasing function. Next, you have your case 2, which is dy dx is bigger than 0. So when you have a dy dx is bigger than 0, this means you have a positive gradient. And a positive gradient means you have a straight line going up in such a manner. And this indicates an increasing function. And lastly, when you have dy dx is equal to 0, it simply means you have a flat line. So now we have this function y. So let me rewrite this function y first. So once I have rewritten my function y, and I can clearly see that we need to use the third method of differentiation using product rule. So let me du dx first. I get minus 5, and let me find out my dv dx. I should get minus 1 bracket x squared plus 1 to the power of minus 2. Differentiate x squared, some more, I get 2x. So let me cross multiply to find my dy dx. So minus 5 times my v, which is bracket x squared plus 1 to the power of minus 1. So I get minus 2x times minus 5x. Therefore I get plus 10x squared times bracket x squared plus 1 to the power of minus 2. So this is my dy dx. So my job is easy now because I have my dy dx. So I have to simplify this dy dx so that I can continue to see if my dy dx is smaller than 0 or bigger than 0 or equal to 0 for x is always bigger than 1. So let me simplify my dy dx further, which means I have to combine these two terms. So let me combine these two terms by making the denominator the same. And in the end, you should get 5x squared minus 5 for your numerator, and your denominator should be x squared plus 1 bracket to the power of 2. So with this simplified answer of my dy dx, I can go on to conclude that my dy dx is a positive. So how do I prove that? So as you know that anything to the power of 2 is always positive. So your denominator is always positive. And so now we only need to pay attention to our numerator, which is 5x squared minus 5. For x is always bigger than 1, you should realize that 5x squared minus 5 is also positive. So therefore, I can conclude that my dy dx is always positive. And dy dx is always positive means it's an increasing function. My y is an increasing function. So never go and memorize, because if you memorize, you forget. Now, let's take a look at another question. So clearly, this is differentiation of individual terms. So let me rewrite the question. So y is also equal to x to the power x to the power of negative 2 plus 1 over 6 x to the power of 3. It's supposed to be x to the power of 3, but let me do x to the power of 2. The concept is the same. So I have done the differentiation, which is given as written. And now, part 2, the x-coordinate of the stationary point, which means I have to find dy dx when it is equal to 0. And when the dy dx is equal to 0, that means the gradient is 0, and that means it's a flat line. So now I can equate my dy dx to 0. So once again, bear in mind, I'm doing y equals to 8x to the power of negative 2 plus 1 over 6x to the power of 2 instead of x to the power of 3. So now, I just have to find my x. After equating my dy dx to 0. And clearly, you will get x to the power of 4 equals to 18. And with that, take out your calculator and punch your calculator. You should get plus or minus square root 18. The number is a bit weird here. You know what? Because I'm doing 8x to the power of negative 2 plus 1 over 6 x to the power of 2 instead of the given question. But it's okay. So now I realize my mistake. So it's okay. Let's carry on this mistake and do it as if the question is y equals to 8x to the power of negative 2 plus 1 over 6 x to the power of 2. So now I have x equals to positive square root 18 or x equals to negative square root 18. So one is positive, one is negative. And now I have to determine its nature. So I can use second derivative to determine the nature of my stationary point. I have 2 points. So just to refresh your memory, second derivative, which is more than 0, is a minimum point. Second derivative of which is smaller than 0, it will give you a maximum point. So now let me do the second derivative for my dy dx. And I get 18 x to the power of negative 4 plus 1/3. And you can see from this second derivative, no matter what, you will get a positive number, regardless what you sub in. You can sub in a positive number, you can also sub in a negative number. No matter what, you will get a positive number for your second derivative. So this means both points are a minimum point. So I have sub in my positive square root 18, and I get second derivative which is bigger than 0, and that means a minimum point. So the same goes to my negative square root 18. That is also a minimum point. So the key point here is x to the power of negative 4 is always bigger than 0. And now we have come to a new question. And this question says, it's given that y equals to 16 over x to the power of 4, and that z equals to x squared plus 2y. So given that x is positive, find the value of x and y of that. Make z a stationary value and show that in this case z has a minimum value. So what I need to do, I need to sub in my y into my z equation. And what do I get? I get z equals to x to the power of 2 plus 32 x to the power of negative 4. So now, when z is a stationary value, so what it means? So it means my dz over dx is equal to 0. So therefore, I differentiate z with respect to x. dz dx equals to 2x minus 128x to the power of negative 5. And let me equate it to 0 because I want to find the stationary value, which means I want to find the stationary points. So now, what do I get? I get the question simplified, and I have 6x to the power of 6 minus 64 equals to 0. So clearly, I have x cubed minus 8 bracket and x cubed plus 8 bracket equals to 0. And x cubed minus 8 equals to 0, and x cubed plus 8 is equal to 0. So therefore, I get x cubed equals to 8, which gives me x equals to 2, x cubed equals to negative 8. My x is negative 2, which is rejected because the question clearly says x is positive. Now I have to find the value of my y. So when x is equals to 2, my y is equals to 16 over 2 to the power of 4, which gives me 1. X equals to negative 2 is rejected, so I don't have to find the value of y when x equals to negative 2. So now I just have to prove z has a minimum value. So I do a second derivative test. So I get d square z over dx square, which is 2 plus 640 x to the power of minus 6. And you can clearly see that this second derivative gives me a positive or negative number. I'm not sure. I have to check it by substituting my x equals to 2 into this second derivative. So take out your calculator and punch your calculator. You should get a positive number. So when you get a positive number, this means that your second derivative is bigger than 0. Positive is always a smiley face, and that shows a minimum point. So I have also proved that z has a minimum value. So I hope you understand the approach to this question. So we have come to the last question of this topic, and I would like to my students to take this question as an assignment. So we have come to the end of today's lesson. But before I end my lesson, as usual, I would like to give a summary of what we have learned so far. So when dy dx is equal to 0, that means our gradient is 0. This shows a flat line. And flat line usually is also called the stationary points. So other cases, when dy over dx is bigger than 0, this clearly shows our gradient is positive, and the line is a uptrend line, and this shows an increasing function. So conversely, when dy dx is smaller than 0, it's a downtrend line, and this shows y is a decreasing function. And when it comes to stationary points, we have to determine whether it's a maximum or minimum points. We can use the second derivative method.
So when the second derivative is smaller than 0, that means it's a frown face, so it gives a maximum point. The other way, if the second derivative is positive, it's a smiley face, so it gives a minimum point. So in the case your second derivative is equal to 0, and you can't conclude anything. Remember that. When your second derivative is equal to 0, you can't conclude whether it's a maximum or minimum point. So what you need to do, you need to use your first derivative and find out whether it's a maximum point or minimum point. So this is the summary of what we have learned today, and I hope you have enjoyed everything so far. Hope to see you again. Bye.